Hello, my name is Boots, and I'm a goose, and I really like type-safe data APIs. And specifically, I'm a big fan for no particular reason, well, for a lot of particular reasons, I guess, of the honk stack. First and foremost, I think it's an excellent abbreviation because it sounds like one of my favorite noises ever, which is honk. Second favorite noise is which I tend to do when I'm excited or angry. But honk isn't just a noise that geese make, it's also a stack, a technology stack for people who write TypeScript on the internet. In this case, it refers to Hono, DrizzleORM, Neon, and Cloudflare. And today I want to use all of these components of the stack in order to build a simple semantic search application for recipes, like human recipes that humans make for food. Or geese also like food. I particularly like breadcrumbs and mainly just breadcrumbs. Aside from that, let me think. I took some goosey notes here. So I introduced myself, I talked about what I want to build, and then I have a task list of things to do. All right, so honk app. We're making a honk data API. It'd probably be good to explain all of these things, and if you already know all these things, then you can skip ahead, hopefully, if my honk editor puts in chapters. But the H in honk stands for Hono, which is it's a TypeScript framework for building APIs. It looks like Express, but it's not. It's built on web standards. It's a bit more modern, and because it's built on web standards, it can run on all sorts of environments like Node, Netlify, Vercel, Bun, Dino, and Cloudflare, which is actually what we will be using today. We'll be using Cloudflare Workers. And that's to be able to deploy the code onto the internet so that everyone can enjoy our goosey code. Aside from that, the O in honk, somewhat or very intuitively, stands for DrizzleORM. Drizzle is a type-safe data, type-safe query builder for relational databases. So think of Postgres, think of MySQL, and think of SQLite. I, as a goose, particularly like Postgres, and it turns out that the folks at Neon, which is a serverless Postgres company, have built a very robust system for spinning up a database and not having to think too much about scaling. And personally, because I'm a solo Goose developer, I don't want to have and manage a database. I would rather someone else do that for me. And their entire philosophy of building is very in line with Cloudflare Workers, which are also serverless. They have an HTTP connection client from Cloudflare Workers that plays very nicely with DrizzleORM and Hono, and avoids some of the pitfalls of having to establish a Postgres connection from a serverless function like a Cloudflare worker. So that's our stack, and I think we'll have to explain what I meant by semantic search in a little bit, but let's just get started. So we have some example apps right here. There actually is one called Retrieval Augmented Goose, which would be helpful for us. So I might look at that for reference code at a certain point in time. But what I'd really like to do is just get some code scaffolded. A honk app scaffold. Honk app scaffold. Honk app scaffold. Honk app scaffold. I want to scaffold my honk app. So I'm going to paste this into my terminal. This is just an npm create honk app right here. I'm going to show you something that, because I've got the inside track with the honk stack, I want to show you something special that you can do. Don't tell the creators that I told you this because I think it costs them money. But if I put this extra dash dash right here and then a dash dash hatch, which is what geese do from eggs, if that wasn't clear, then I think I should. You know what, I'm going to use pnpm because I'm a goose. I think this should. Yes, okay, so this prompts us, what do we want to build? Well, like I said, I want to build a semantic search recipe app API thing. Okay, so I would describe right here, I want to build I'm going to type exactly what I said. Semantic search API for recipes. But actually, I want to implement the semantic search on my own. For now, just prop up a keyword search API for recipes. And I think that's okay. I will say human recipes. Not made from humans, but for food that humans would eat, like breadcrumbs. I think everyone enjoys a good breadcrumb, personally, as a goose. That's what I think. We can call it goose recipe search. Not that the recipes don't have to do with geese, because I can't support that because I am a goose. But I'm a goose and I'm making a recipe search app, so that's why I called it. So this is the folder in which all of my code will live, is goose recipe search. And then I have a selection for templates here, so I can do a Neon template, a Supabase template, a D1 template, that's like SQLite on Cloudflare, or I can just get a sample API. For the time being, I like Neon, and I'm going to select that one. Okay, and now it says the selected template uses Neon, Templon. Do you want the create honk app to set up the connection string for you? I do. So normally you need a database connection string. That's a whole lot of work, right? So let's have the create honk app do that for us. Do we want to install dependencies? Yes. Do we want to initialize a Git repository? Yes. As a goose, I love Git. Both start with G, which I think is really awesome. Okay. I'm going to authorize the honk CLI to integrate with Neon. So now I can see all of my projects from Neon. I already created a Neon account, so that makes it a little easier for me. I guess if you haven't created one yet, they have a generous free tier for human and for geese. I will select this project, Goose Recipe Search. I already created the project beforehand, just so you know. You can have branches for your databases in Neon, which is a pretty cool thing. But I'm just going to use the main branch. I'll create a new database. And let's see here. Okay, the name of the database will be, I don't know, give me a suggestion. Right, you're not there. Okay, Goose. It's just going to be Goose. The name of the database is Goose. Okay. Perfect. So now we have a connection string for our Neon database. We're installing dependencies. We can wait for that a little bit because, you know, it takes time. And it looks like cool. All right. Everything seems to have worked. So now I can change directories. Look at all these instructions right here. These are important. So to set up the database, I can change directories into Goose Recipe Search. Here, wait, I'm going to do this in a separate terminal window over here. Don't mind the name that's right here. That's just on my friend's computer. I can cd Goose Recipe Search pnpm. I don't actually need this run because I'm using pnpm, but I'll use it anyways. db setup, so that should set up my database. I'm gonna, lots of stuff going on here. We should probably unpack that at some point, but I'm just gonna see if it works. Optionally, I can use Fiberplane to explore my API. Fiberplane is pretty cool. It integrates with Hono APIs locally and gives you some goodies for executing requests against your API. So I will do pnpm run Fiberplane. We'll see if this works. Okay. And that's going to start to set up Fiberplane. So I should also just kick off my... okay, I'm in this other terminal window. I'm going to kick off my API. Oh, I need to cd goose. I have so many goose repositories. Okay, pnpm run dev. Perfect. that's running. Okay. And it looks like I have both my API running right here. It says, welcome to the recipe API. You might be wondering, how did it know it was a recipe API? And that's because the people at Create Honk app, they the whole thing I said, don't tell them, and I told you about this with the hatch thing. I think they use some AI. That's the word on the street, the artificial intelligence. They use artificial intelligence to write some boilerplate code for your Honk app. So I just described that I wanted a recipe search app, and they seem to have written that code. Whoops. So that's cool. All right. I haven't inspected the code yet, which maybe we should do. Let's see if anything breaks. Okay, so this over here, this is FiberPlane is running, and okay, this interface shows me all of the routes that should be in my API, and then I can execute requests against those routes. So similar to when I just opened this, I made a request to the root route, and I got this welcome to the recipe API. And if anything funky happened, I can, so I just opened the timeline over here by pressing GT, and I can look at a timeline of requests, like see what environment variables were present and headers of the rest. Okay, that's fine. Let's see, do I have any recipes in the database? Ah, I do. Cool. Looks like, so when I ran that DB setup, it seeded my database with a couple of recipes. So in this case, I've got, here, we'll get rid of the timeline, spaghetti bolognese, chicken curry. I don't know if I support that. Why chicken? It seems kind of, there's no need to add the chicken. You can just have a curry. And then a vegetable stir fry. That's nice. Vegetables, I can get on board with that. So that's all cool. Nice. Let's look at the code. The code over here, if you remember, we're going to make a recipe search app. So I'm going to open my code editor, which happens to be a thing called Cursor. I like Cursor. It has artificial intelligence, which I mentioned earlier, which is it's a cool thing that I don't know how it works. And let's look at the README, because that's a good place to start for any code base. This README shows the structure of the API and tells you a little bit about how to get started and blah blah blah. And now it has links to the honk.dev website. That's nice. Do you remember that website? I showed you that like 10 minutes ago. Okay, so in this README, actually, is there a better way to look at it? Let's actually look at it as Markdown. Okay. We should have a source index.ts, which is the entry point for a Hono API. We have this DB folder that, contains a schema, which is our database schema written with Drizzle. Then we have a seed.ts file, which can seed the database with data, which we already did when we ran DB setup. And then we have like an example file with called an example dev vars file. I think that's just the same thing as like an environment file, but meant for Cloudflare Workers. So if you didn't know that, now you know. Over here we have a wrangler.toml, and that is for configuring a Cloudflare worker. And then we have some configuration for Drizzle, again the ORM, the query builder for relational databases. And then we have a TypeScript configuration because we're using TypeScript, and then a package JSON. So that should be it. We have an overview of some commands. I don't like that when I double click that it goes to the source. Here, if I run db setup like I already did, that says that this is a convenient script to db generate, db migrate, db seed. So that's all like Drizzle related, the generating and migrating. And the seed is that script right here. Other than that, we have a development server, which we can run with npm run dev. pnpm. Why doesn't it say pnpm? I'm using pnpm. That's ridiculous. And yeah, I already ran this. That's why my API is running. Isn't that cool? And I got some instructions for as you're developing and when you want to actually deploy your app and all that kind of stuff. So that's cool. I think it'd be nice to look at the code that is actually executing. So if we look here, all right, here was our home route. And remember, it says welcome to the recipe API. So this is this is a Hono is imported from Hono. And then we create an app like this by saying new Hono with those little, we invoke it, we make an instance. And we add this generic parameter right here, this TypeScript thing. We add this generic parameter of bindings, which tells Hono, hey, in your environment, you have a database URL. And that's important because in a Cloudflare worker, which this is, you don't have your typical process.env like that, which you normally have in like a Node application or an Express.js application. Instead, you always access your environment variables on this thing called c.env, where the c is your context. And then your env will have any variables that you added in your .dev.vars. So in this case, well, I'm leaking my my database connection string. That's not smart. I should revoke that after this. So that's where I define my database URL in .dev.vars. There's an example, always included in the in a honk app example, and right, this database URL is what is ultimately going to be right here. The thing is, TypeScript needs to know that we expect a database URL right there. That's fine. We can add an FP. Oh, we don't need that. Okay. So that's why we put it right here, and then tell Hono, hey, you have these bindings. So getting all recipes from the database. That's cool. We define the route with app.get, and then we do this magic right here to set up. So this sets up our neon connection string right here. And then we create the Drizzle client to craft queries by wrapping Drizzle in this like neon client right there. And then we have a DB, and we can do stuff like database select from, and then tell it to select everything from recipes and then return it in the API. What does recipes look like? That's a great question. Thank you for asking. Recipes, we don't have users. Let's get rid of users. We don't have users. That's, yeah. Right, so here we have some helpers for creating the database table of recipes, and it looks like we have an ID, a title, some ingredients, some instructions, and a timestamp for when we created the recipe. I'm gonna goose yawn. 1 second. No, thank you. Okay. That looks fine. It looks whatever. Yeah, that looks fine. Okay, so then we have a bunch of other, cruddy like routes in order to create and interesting. Create recipes and stuff like that. Yeah, I don't know. Is there anything else? What else should we do here? Oh, did we have a search? Yes, we do. Okay, so we can search by keyword right down here. And it looks like we're searching the title for keywords. And if you remember a long time ago, very long ago, like almost 20 minutes ago, I said that I wanted to build a semantic search API with you today. And I still do if I have enough battery, which I think I do. What is semantic search? That's a very good question. Again, you keep bringing the hits with all of your questions. I could explain this really quickly. If you already know what it is, then if there's a chapter, just skip this section. But semantic search, okay, what is not semantic search? I would say keyword search is not really semantic search. And why is that? Keyword search is something like if I wanted to look for a pie. All right, I know. We can actually demonstrate this in the API. So here we have this spaghetti bolognese. If I wanted to look for recipes, also I'm going to show you a cool thing. Okay, with Fiberplane, if you sign in with GitHub and Fiberplane Studio, which again, this is all running locally, you can make a bunch of AI-powered requests against the sample API. So I could, for example, what? That's silly. I think that's a bug. Gasp. Okay. Let's do this. Okay. So if I click this magic wand or do Command G, it should fill in some request parameters for me. Perfect! Wow. I don't know why it has an ID parameter here. That seems wrong. Uh-oh. Oh, you know what? Very interesting. This route will never execute because it was defined too late. Oh, that's super interesting. Okay, so we already found a bug. Okay, I should explain what just happened. So I wanted to generate request parameter for this search API right here. And the thing is, I noticed that yes, we have this keyword and spaghetti. And actually, let's execute this request, just see what happens. But the telltale thing from here is that this is our active route right now, and we have this path parameter of ID, and it was set to search. And what this means is that our Hono app is actually, and this happens in a lot of APIs I've seen, our Hono app is going to actually execute this route instead of this one when we want to make a search. So there we go. I get an internal server error. Why do I get an internal server error? Let's go to the logs. Well, it looks like this might be kind of hard to see. I don't know if we can trace this back as easily to... Can I find a link? I want a link to the error. Nope. Not getting the link. Bummer. Well, I'm getting a neon database error that there was a non-integer passed to a query. I already know what's happening, so I can tell you right now. What's happening is instead of executing this route, we are executing this route. The ID is trying to be parsed as an integer. It's not an integer, and that makes this query mess up. So what do we want to do? We want to move our route definition like this above to right here. And that way this route will execute before this route. Oh wait, no, not there. I'm sorry. Right here. So we have this app.get of /API/recipes/search. We want to define that before we have this /API/recipes/ID. Otherwise, Hono will think that when we make a request to this, that search is the ID we're looking for. So if we define this first, then this route will be hit before this one. Okay, so did I save? Did not. I should save. Give this a second. Okay. So here, /API/recipes/search. Okay. Perfect. We just made an empty search query and got no results. That's fine. Right now I just pressed Command G and want to do a keyword search. So it looks like Fiberplane Studio kind of inferred that I want to do a keyword search with curry in it. And it looks like that works. So I found something with curry in it. That's a keyword. Now, do you remember I did want to search for bolognese? Spaghetti bolognese. Let's make sure that shows up. So, did I spell? No, I misspelled spaghetti. Okay, now spaghetti bolognese comes up. That's perfect. Now, here's the thing about keyword search. What if I put in like pasta? No results. That is a little bit of a limitation, because if someone is searching our vast compendium of, how many recipes do we have? Like 5? 3. 5. 5 recipes. No, 3 recipes. We have 3. Someone's searching our vast compendium of 3 recipes. I would expect that if I searched for pasta, I would see, at the very least, a spaghetti. So, how could we resolve this? We resolve this with semantic search. Semantic search is very interesting because it can take kind of the vibe of whatever you're searching for, look across your database for things that kind of match that vibe, and then return those instead of just looking for a direct match keyword or something like that. In this case, well, okay, I should probably talk a little bit about how that works. Yes. Yeah, otherwise this is going to be super confusing. Okay, we're going to talk about that. By the way, so this person right here wrote a blog post on the Fiberplane blog about semantic search with the honk stack. We're going to take some inspiration from this post. It's called Retrieval Augmented Geese, which I wholly support as a blog post title, as a goose. And there's a conceptual primer in here that's okay. It's all right. And it goes over the concepts you need to know in order to understand how we will implement semantic search. So, right, the first thing is a vector. Just vectors are lists of numbers. Let's put it that way. So a vector of length 2 looks like this, has 2 numbers. Length 3 has 3 numbers, etc. That's good. We know that now. Now, what are embeddings? Because we're going to need to use embeddings to do semantic search. So embeddings are vector representations of words and phrases, which sounds silly and probably just sounds meaningless, but just stick with me for a second. So there's a really good analogy here that comes from someone named Linus Lee, who has a cool website. Very minimal, but very cool. He talks about color. And so with color, there's a difference between saying blue and then specifying an RGB value, which is a red, green, blue value. So you could say blue, or you could say RGB 00255. In this case, RGB is a vector of length 3, because we have 00255. Now, if you wanted to mix a little bit of red into your blue, how would you do that? How would you represent the resulting color? If you're just relying on keywords like blue, then you would need a new name. So you would have to say purplish blue or something like that. So you just invented a new color name, and then that's how you reference your slightly blue with a little bit of red. However, if you have an RGB value, you can just do math, and you can just add a tiny bit of red. So in this case, you would do RGB 20, so that's the 20 of red, 00, plus RGB 00255, that's a ton of blue. And then you get this resulting vector right here. And then just through math, you've created your new color that you wanted. So that is a consequence of representing colors with vectors of numbers. So we can do math on it, we can manipulate it, we can have a good old romp in the pond with it. Embeddings refer to a way that we can do this kind of math on human language. So embeddings are just like very, very long vectors that represent some sort of like the meaning of a chunk of text. So you feed it a couple of words, maybe just one word. You can feed it a sentence, and then an embedding will come back as a large vector that kind of represents, what does this thing mean? And so a really cool example that comes from some of the early papers. I haven't actually read these early papers. I've just read, because I'm a goose and I'm not really good at reading machine learning papers or natural language processing papers. But applying this to human language, if you would have vector for the word king and a vector for the word man and a vector for the word woman. What you could do with this kind of word math is you could subtract the vector for man from the vector from king, and then you would add the vector for woman, and you would actually get a vector that's really, 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 really close to the word for queen. It's probably closer to that word, that vector for the word for queen, than any other vector. Sorry, any other vector for any other word. And this whole math on words to find similar concepts is exactly what we need to do to implement semantic search. So, the last piece of the puzzle here is that we have to think of how similar two words are, or given their vectors. So, for semantic search, what I will probably want to do is I want to look at, let's just say for the title for now. I want to look at the vector I want to make vectors from every single title for every single recipe in the database. And then I want to go through, so if the user looks up pasta, I want to make a vector out of their like search for pasta. So a vector for the word pasta, and then I want to compare that vector to all of the vectors for the titles of recipes in the database and find the most similar ones. And that's just math. And we'll use something called cosine similarity, but that we don't need to worry about that for now. Okay, so I'm going to check in on my to-do list. It's been a long time since I did that. So what did? We scaffolded the app. We connected it to Neon. We created a database, we spun up our studio, we checked our seeded data. Wow, we've done so much stuff. It's been a really long time. I've had a lot of fun. I hope you have too. You probably haven't, but it's okay. We make some requests, and then we implement a keyword search route. I mean, we already did that, like the AI did that for us. We don't need to look. Maybe we should actually look at what the queries look like. That'd be kind of nice. But it's been so long. We've been at this for so long. Let's just, okay. It's time to implement vector search. All right, vector search. Yes, we have a table for recipes. What do we need right now? Let's call this, we need a column in our database called embedding. And hopefully vector works. I don't think vector works. Does vector work? PG vector builder internal. I hope that works. Let's try. Okay, so I added this column to the database. I have this dimension, the AI really suggests this, but it's correct. I have a dimension of 1,536. I will explain why we need to know that in a little bit, and where it comes from. Okay, but let's say I'm here. So the first thing I want to do is I just modified my schema. So I want to do pnpm-db generate. That generates a migration file. And, oh, yeah, it looks like, perfect. Okay, it dropped the table that, if you remember, there was a users table. I just got rid of that. So it's dropping that table, and then it's altering the recipes to add a column called embedding that is a vector. And let's hope that works. Okay, so pnpm, so we generated the migration, now we need to apply it. And we're gonna try. Okay, we got an error, and I think I know why. Yeah, type vector does not exist. Here's what we will do. We need to create extension if not exists. Oh, is it PG vector? I don't remember. I'm going to add this statement breakpoint. I don't know if it's important, but it might be. Okay, I'm manually modifying this database migration right here. I think it's just PG vector. I should do that. Okay. So I need to create a database extension in order to, oh, that didn't work at all. Okay, so it turns out I need to go into Neon and enable an extension that allows us to use vectors. Thank you for your patience. All right, I'm here. I want to go to the Goose database. This is the, by the way, this is the Neon web UI. It's quite nice. Here, I just, how do I add? I want to add an extension. Can I do this? Main, Goose. Okay, we're just going to try this. Create extension, if not exists, PG vector. Oh. Okay. Integrations? Oh my gosh. I used to know how to do this. How do I do this? Vector. No. Enable PG vector. So I just pressed Command K and I'm asking a question of their AI assistant. Oh, it's just create extension vector. Dang it. Okay, let's see if we can actually do this. Create extension if not exists vector. I feel silly because I'm a silly goose. Let's try this. Goodness gracious. I wish I would have done that to begin with. Didn't even need the statement breakpoint, I don't think. Let's see. Okay, we can do something fun here. I'm going to go to pnpm run TV Studios. This is DrizzleKit Studio. It's a nice little tool for inspecting your database. So this is connecting to, nice, it's connecting to my production database at this point. And I can see that this embedding column was added. So I can see every recipe in my database. I could modify it if I wanted to. Even add a new record, I guess. So let's add a record. We'll say pineapple pizza. Pineapple. Ingredients are pineapple, pizza, and angry Italians. And the instructions are just do not deliver this to anyone in Naples. And that should be fine. Created at default. That's good. And we'll save. All right. And just to show you that that is indeed what happened, I'll go back to Fiberplane Studio. Get all the recipes from the database. Look, pineapple pizza is there. And I can even search for it. I'll do keyword pizza. Oh, are we not case insensitive? That's not a case insensitive search. Okay, well that's a bug with our keyword search. Yet another reason we should have semantic search. Okay, that's all good. Let's go to, I mean, we can close all this, right? Right, we have a column in the database that can hold an embedding, which is great. Now we need to create embeddings, and this is a whole thing. This is a whole thing. Can I finish this in like 20 minutes? Do I have enough battery? Probably. Will I try? Do I have a meeting? I need to check if I have I'm a very busy goose, and I don't know if I just accidentally hold for a second. I need to check if I have a meeting. What else can we do? I have a meeting in 18 minutes. Okay, let's see if we can finish this in 18 minutes. We gotta go. We gotta go. We gotta go. This is gonna be messy, but I believe in us. That means within an hour we spun up an API with vector search, which is pretty cool. If we can finish this. I think we can finish this. If I stop talking, we will definitely be able to finish this. Okay. First of all, let's just commit all this garbage. Initial commit. Okay, that gives me an idea of what we are actually modifying along the way. Oi voy. PNPM add OpenAI. All right, why am I adding OpenAI? It's because they have a what's called an embeddings model, and they can help us create embeddings for all of the records in the database. So aside from that, I'm going to need a script that can create embeddings for all the records in the database. So I'm actually going to reuse the seed script. So I just copied the seed script, and in this case, I don't want to seed recipes. I actually want to select schema.recipes. I want to get all recipes from the database right there, and create embeddings. And all right, so what I'm going to do is get all recipes and then create an embedding for every single recipe title and store it in that column called embeddings. So actually list that out. Oh, wow. It's like it was listening to me talk. Okay, so I have this for loop. And it's not actually that correct yet, but we can fix that. Real quick, this is bothering me. Database, okay, so recipe. I want to change the log that happens when the script runs, so that if there's an error, it says error during recipe embeddings creation, and if it's successful, recipe embeddings created successfully. I also want to make sure that I can execute this script. So we're just going to do, we're going to log each recipe title in this loop. And then we're going to just wire the script up in, right here. So if I run db create embeddings, so this is in my package.json scripts, then I should just get lists of every single, right there, every single record in the database. Now, what we need to do is use OpenAI. Whoa, we're running out of time. Okay, I want import OpenAI from OpenAI. And I'm going to need the API key. So const OpenAI, yeah, that's fine. And then that sets up our client after we configured our environment variables right here, so that should be fine. I'm going to throw an error if the API key is not set. Down here, what I want to do is perfect. So this calls OpenAI's embeddings model, creates an embedding, uses this model right here, which is text embedding 3 small. And actually, what we want to do is create an, so the input right here is the recipe title, so that will give us the embedding result from the call to OpenAI. And the actual embedding, title embedding will be in this path right here. So embedding result dot data 0 embedding, and you can kind of see all this in the TypeScript types, which are kind of hard to see here. But you can go to type definition. What? You know the type definition? Okay, that's weird. I don't know why it's here. Go to type definition. Ridiculous. I feel like I am failing as a TypeScript developer right now. My goodness. I'm tired. I need to review this in my spare time. Anyways, okay. So here we get the embedding result, we get the title embedding, and then we want to update the record in the database for this recipe. So how will we do that? We do db.update, we update the recipe schema, we set the embedding equal to the title embedding, where the ID, schema.recipes.id, is equal to the recipe ID that we're updating. And we need to import this helper from DrizzleORM. You see that that was added up here. And that should just about do it for everything in the database. Let's try calling this. This will execute it sequentially, which we could do it in parallel if we cared about performance, but we are geese. Performance is not our primary concern. Okay, db, what was it? db create embeddings. We're gonna get an error. Yeah, because I forgot the API key. Right. Oh goodness. Am I gonna leak an API key? I might. Let me think. I really don't want to leak an API key, is the thing. How do I do that? I'm gonna leak an API key. Okay. What do I want? No. Pause. How do I pause? Okay. And we're back, magically. Video was edited to remove me generating an API key. Here we have, this is what it would look like in your dev.vars. You would add an environment variable that had your OpenAI API key, and that would make it accessible after we configure our environment variables right here with .env. That would make it accessible to the process that we're running in order to seed the database. So, create embeddings. That's what we're doing. Going to run this. It's going to take a little bit of time. Looks like it worked. And if we want to check our database, DB Studio, fire that up, go to Drizzle Studio, and we can see, cool, we have an embedding for every single one of these recipe titles. So I promised I would let you know why the schema had this dimensions 1536 right here. So when you add a vector as a column in Postgres, you need to tell Postgres how long the vector will be so that it knows, because it wants to do math on this column, and so every vector in this column must have the same dimension. That makes the math easier and possible. And right, 1536 happens because we can go here, OpenAI, embeddings, small model, vector dimensions. So, let's see here. Yeah, so we have this text embedding 3 small right here, and the embedding size is 1536. So yeah, that's why it's this this embedding model produces vectors of length 1536, and we needed to specify that in the database. So we did right here, and then we created the embeddings right here and updated the database with them there. So now they exist in the database. That's great. Now what do we need to do? Oh my goodness, clock is ticking. Clock is ticking. I have 7 minutes before my meeting, and I really want to finish this. Okay, let's rename search to search keyword. That's fine. And let's copy this and do search semantic. We're just going to accept a query parameter called query, which is a little confusing when you start reading the database, but it's fine. In this case, we'll write a to-do, implement semantic search. What components is that? So does that require? That means we need the embedding of the query. And we also need an OpenAI client in here. Const OpenAI. And like I mentioned earlier, we actually need to tell Hono that we have this on the environment, the OpenAI API key. So that should be fine. And we probably, because TypeScript is getting mad, not that. Yeah, that's fine. All right, we're going to throw errors, or return erroneous JSON if API keys are not set. cool. We're going to do an opaque error to the end user if we didn't actually configure our API key. And if the user did not send a query, that's on them. That's their problem. And we'll say query is not required. That way, TypeScript is fine with what we're doing down here, which is passing this query, which is pretty much guaranteed to be a string, into the OpenAI embeddings model. So we're creating an embedding from this query. That's our result. Our actual embedding is embedded in this long path right here. So now we get the query embedding. Now what do we want to do? We want to get some search results going. How do we get search results? So we need a special query. Wow, how does it already know this? That uses cosine similarity. How do we use cosine similarity? Oh, goodness. Okay, similarity query. Does that not exist somewhere? Cosine similarity is like some math that shows us how similar different vectors are to each other in the database. So in this case, query embedding right here is the embedding for the user's query, which would be like pasta. Cosine similarity will do math between all of the things in the recipes table. I'm losing steam. I'm so sorry. I need more goose juice. Oh my goodness. I don't think I'm going to make it. This is the second time. Okay. Let's see if that one blog post that one guy wrote is actually helpful. Cosine? Do we have cosine similarity here? Please show me cosine. Nice. Okay. Let's see if this works. I'm copying code from this blog post. And hopefully this works for us. Okay. That's a lot of difficult things to... Okay. We have cosine distance. That's the thing. I need a cosine distance. Oh. All right. Drizzle SQL. What is this? That's a good question. All right. So Drizzle exposes this thing called SQL that allows you to write SQL, raw SQL. And I just renamed it to Drizzle SQL to make it, more obvious what it is. So here I create a kind of a query. I am okay. Just modifying this real quick. I'm so sorry. We need a similarity cutoff. Thank you. Oh, all right. Okay, we might actually have almost everything we need. And then I can describe it. I'm so sorry. Okay, what did I just do? A lot of coding and not explaining what I was doing. I'm so sorry. We craft this similarity query, which is basically just like a type-safe SQL statement, so we know it returns a number. And then we, there's my meeting. Pass it into Drizzle down here. So we're saying select these columns. These are just the normal columns from the recipe database, ID and title. And then this similarity score. So there's going to be some additional math that Postgres does in order to determine how similar each of the records in this table are to the user's query. And then this tells us, we're selecting from recipes. And then we have a where clause here, which says like if the similarity score is only keep it if it's above a certain cutoff. So the similarity score is always from 0 to 1. 1 would be like this is the same thing. 0 is like there's nothing to do with each other. There's a little bit of like just magic in terms of tuning that correctly for your semantic search application. But after that, we want to order everything in descending order by the similarity score right here. And limit it to, let's say, 3 result. Let's just do one result? No, 3 results. It's search. And then we return all that. I have no idea if this is going to work. Oh, I think I need to restart my API so that the environment variable change takes place. Members of my team are getting ready for the meeting that they're about to join. So let's just go back to Fiber Plane Studio and search semantic, query pasta, see what happens. We get no results. Okay, what if we make the cutoff smaller? Hey! Okay, and what if we have like basically no cutoff and we limit it to 1,000 just to see how everything ranks in the database. So if I search for pasta, the most similar thing is spaghetti bolognese, then it's followed by pizza, then it's vegetable stir fry, then it's chicken curry. That's kind of interesting. Anyways, I need to go. Oh, goodness. Okay, thank you. Bye.
Yes.
We recording?
Yes.
All right. Hey, this is Boots the Goose again. You can tell that time has passed because I'm sitting in a different location. I wanted to provide a narrative conclusion to what we did, which is first, set up, oh, also this is my friend Sir Honks a lot. He just wanted to hang out for this video. Say hi. Okay, he's shy. What did we do? We set up a honk API, used the create honk app CLI. Then we connected it to a Neon database, which was very easy. After that, we seeded the database with some recipes. And then we started creating embeddings for the titles of our recipes so we could do semantic search across all the recipes in our database. And to do that, we enabled the vector extension on Neon, and then we connected our API to OpenAI in order to create embeddings, vector embeddings for our searches and stuff. And then finally, we created an API route that performed semantic search on all of our recipes, which gave us a simple semantic search engine. Once again, I'm Boots the Goose. Thank you so much for watching 1 hour of a goose code. Thank you. Honk!